7.3, systems of non-linear equations. So what's different in this section is the equations are not linear. Now, do you know what a linear equation is? A linear equation is like y equals mx plus b. X and y are both first power x and y. So both x and y are first power, and that means the graph is a straight line. That's what we call it, linear equation. So a nonlinear equation has x or y not first power. So for example, this equation is not linear. And the graph is this upside down U shape, what we call a parabola. So like if you have y equals minus x squared plus 5. Whereas this other equation is linear. So what they're giving us in this problem, the first equation is linear. It's a straight line. The first equation here is this straight line graph. And the second equation is not linear. It's the upside down parabola. And they're asking us to figure out where the two intersect. Right here and right here. So, we're not going to graph them, but it's kind of nice on this first problem. They're showing us the graph. You can graph them on Desmos or your graphing calculator or something. And we're seeing the graph, and we're trying to find out what those points are. Now, we can see down here already, there's the answers. Meaning, x is -3, y is -4. Will make them both true. Let's see it. If you put in x is -3, right there for x, -3, and right there for y, -4. Is that equation true? 3 times -3 is -9, plus 5 is -4. See how it makes that equation true? Let's try the other one. -3 for x, -4 for y. Now, -3 squared is 9, positive 9, and then that extra negative in the front makes it -9. Plus 5, yep, that equals -4, doesn't it? So you can see -3, -4 does make both equations true. And here is the point right there, -3, -4, right? That's back 3, down 4. So there's that point. That's an intersection point, meaning it's on both graphs, because it makes both equations true. That's what it means when two graphs intersect. That dot is a dot that's on both the straight line and is on the curve. So if you're on a graph, you make the equation true, right? Like all these other dots on the straight line or all these other dots that are on the curve, they make their particular equation true. So it's only this dot and this dot that are on both graphs, so they make both equations true at the same time. So -3, -4 is one of those. We can see that makes both equations true. And the other one, if we come in here and we test it out, it'll work also. If we do 0, 5, x is 0, y is 5. X is 0, y is 5. That's true, right? 5 does equal 3 times 0, which is 0 plus 5. And here as well, 5, 0. -0 squared plus 5 is 5 equals 5. So you can see that over 0 up 5, 1, 2, 3, 4, 5, makes both equations true. Thus, it's a point on both graphs. It's an intersection point. So, how did they find these points? How do we go about solving two equations at the same time that where at least one of them is not a straight line, at least one of them is not linear? In the last two sections, 7.1, we solved two equations that were linear, both straight lines. In 7.2, we solved three equations that had three letters, x, y, and z, that were all linear. They were all x, y, and z to the first power. That was three-dimensional, so those actually represented three planes. that intersected. But now we're back to two-dimensional, x and y only, but one of them is not linear, 7.3, non-linear. One of them is not a straight line, one of them's curved. So you're going to get more than just one answer. Sometimes two answers, sometimes three or four answers. We'll see as we do this problem. So how did they actually find those two answers? Let's go to some fresh screen where we have room to write them down. Okay, here we are. So what I'm going to suggest is we just substitute, right? Just take all of this, for example, and plug it in right there. So what are we going to get? That'll be 3x plus 5, because y is 3x plus 5. I can plug that in for y right there. And the other side, minus x squared plus 5. Makes sense? I just plugged this in for y in the second equation. So now I've got an equation that just has x. How do we solve when we have x squared with an equal sign? It's very important in this class, and if you're going forward to trigonometry or pre-calc or calculus or whatever, that you know how to solve x squared with an equal sign. Step one, you got to know right away when you see x squared with an equal sign, step one is all about getting a 0. Now I'm going to add a little bit to this. Move x squared to the side where it's positive. So what I'm going to do is I'm just going to grab this x squared. I'm going to jump it over here, and this 5. I'm going to, well, here, let's just do that. How about for starters? Be the easiest thing for you to see, I think. So when that jumps over, it's a positive x squared plus 3x plus 5 equals 5, right? When things jump to the other side, they switch signs. In other words, if you want to be more formal, I just added x squared to both sides, and it canceled out there. That's why it switches signs when it jumps to the other side. Next step, remember we got to get a 0, so let's subtract 5 from both sides, and that gives us our 0. And the other side is x squared plus 3x. Cancel out. So step one, we did it. Get a 0. So you need to know that as soon as you see x squared with an equal sign, you need to think, get a 0. It's got to be an automatic response for you. Step 2, coming on down here now. Step number 2, you can try to factor, or you can use the quadratic formula, the negative b plus or minus the square root all over 2a, that thing. But this one's pretty easy to factor, so I'm just going to factor this one. What do these two have in common? What's the GCF? What do they both share in common? Just take out an x. Like that. That's pretty easy. So you try to factor, and you set each part equals 0. Each part equals 0. So in other words, the x alone is 0, or the x plus 3 is 0. Now, why is that? I don't want that to be just some math step you take. It'll stick with you much better if it makes sense. That's because these are two things multiplying to equal 0. If I said to you, hey, I'm thinking of two numbers and they multiply to equal 0, what does that mean? You know what that means. The first one could be 0, or the second one could be 0, right? If two things are multiplied to be 0, one or the other of them is 0. That's how two things multiply to be 0. Well, that's what this is saying. Something times something, they're multiplying, right? Parentheses, is equaling 0. So the first one could be 0, or the second one could be 0. That's logical. That's why we get 0 in the first step, because we want to be able to take that logical step in step 2. Okay, so the first one is done. X equals 0. That's an answer. Now this one, just subtract 3 from both sides, and we get x is negative 3. So we get two answers for x, but we're not done. Those are just x answers. Now each of those will lead to a y answer. How so? Well, now we plug it in. So I'm going to grab the first equation up here. Y equals 3x plus 5, and I'm going to plug in x equals 0. Y equals 3 times 0 plus 5. Get this over here. There we go. And that's 5, right? Because 3 times 0 is 0. So what answer did we get there? We just got the answer 0, comma 5. Do you see that? Why? Because x equals 0 led to y equals 5. X 0 led to y 5. There's the answer 0, 5 that we saw they had. And now let's do the other one in the same way. So it's, again, using the first equation again. Just keep using that first equation. Same thing, y equals 3x plus 5, that very first equation. So plug in right there, x is negative 3. So that's going to be negative 9 plus 5, y is negative 4. So that's the overall answer. X is negative 3 led to y negative 4. That's the second answer. Those are the two answers we saw that they already had, and those are the two places that the two graphs intersect if you graph the two functions on Desmos or your graphing calculator or something. There it is. That's how you solve two equations at the same time, where one of them is not linear. I just took the first one and plugged in to the second one, solved for x by getting it, got x squared, which always means we get a 0 and we factor, got the 2x answers, and then plug those back into the first equation to get the y going with each of those x's. There we go. Now for number 2. It's going to be similar. Same kind of thing. I'm going to grab this equation and plug it in right there to the other equation. So this second equation is going to become 64 minus x squared, right? That's the left side, equals the right side, x squared minus 64. This is kind of an interesting one. Okay, so now we have x squared on both sides, don't we? Kind of weird. Let's add x squared to both sides. It'll cancel out here, won't it? Because those are opposites. And so we bring down, we get 64 equals, what is x squared plus x squared? It's 1x squared and 1x squared, 2x squared. Now, what are we going to do at this point? How are we going to solve? Well, let me give you another game plan. When you have x squared, let me see, I don't know if I have room to write, let me put it over here. If you have x squared and no x to the first power, see how in this equation we just have x squared and numbers? We don't have an x to the first, like there's not a regular x there or anywhere. Right? It's a little different than the last question. In the last question, you see we had x squared. Right here we had x squared and we had regular x. So that's when you get a 0 and try to factor or use the quadratic formula. But on this one we just have x squared and no x. In that case it's easier. Just get the x squared alone. Step 1. Step 2, do the root and the plus or minus root. That's all you got to do. Just get the x squared alone and the root and the plus or minus root. So I'm going to get the x squared alone. Add 64 to both sides. And we get 2x squared is 128. Now divide by 2. X squared is 64, so I get the x squared alone. And now how do I finish? You put the root, but don't forget, plus or minus. Really easy mistake to make. Don't forget, because an x squared, that could be a positive or negative, right? We know it's going to be 8. X could be positive 8 or negative 8. Either one squared will be 64. So there's two answers for x, positive 8 and negative 8. Now, we've got to take those two x answers, and each of those will lead to a y answer. Let me bring it over here carefully. So I'm going to take it right over here. X is positive 8. Oops, let me write that a little bit better. X is positive. So I'm going to plug in. Now, what am I going to plug into? Either equation, doesn't matter. I'll just grab the first one. So it's y equals 64 minus x squared. We have to find the y value that goes with each of those x values. So y equals 64 minus, plug in the 8 there, 8 squared. Not doing that very well. There we go, 8 squared. And what is that? That's 0, isn't it? 64 minus 8 squared. 8 squared is also 64. So y equals 0. So that x value of positive 8 goes with a y value of 0. Right? X positive 8 led to y 0. And now let's do the same thing. I'll do it over here. X is negative 8. Going to plug into the same equation. Y equals 64 minus x squared. Y equals 64 minus. Now when you plug in, you got to put parentheses around it. So the whole negative 8 is squared. The whole x is squared. That's going to be 0 again, isn't it? It's going to be 64 minus 64. So that's the answer. Minus 8, 0. The x value of minus 8 led to the y value of 0. We got our two answers. Now, how do they want us to write them? Well, they want us to put, this one says the one with x less than 0. So the negative x, that'd be this one. So negative 8 and y 0. This is the x greater than 0, so that's the positive 8 and y 0. That's exactly what they have listed here. There's the x and y answers. Number 3, here we have two equations. So what we're going to do is again plug in the top equation in for y in the second equation. So that second equation will become x times, and I'm plugging in x minus 1 in the place of y, because the top equation tells me that y equals x minus 1. That means y is x minus 1, which means I can replace y with x minus 1. So I do. In the second equation, now I've got an equation with only x, so I can solve it, distribute. X squared minus x is 2. So this reminds us of the x squared with an equal game plan. Step 1, get a 0. So jump this 2 over, or subtract 2 from both sides. Same deal. Get a 0. Step 2, try to factor or use the quad. You know, the quad, negative b plus or minus the square root of b squared minus 4ac all over 2a. You can do either one. This one's going to be really easy to factor. So I'm just going to factor it. It'll be quicker than doing the quad. So what two numbers multiply to be negative 2? It's going to be 2 times 1. And they at the same time add to be negative 1. So the sign in the middle always goes on the bigger number, because the bigger number has to dominate and make the sign in the middle. So negative 2 plus 1, you see they'll multiply. Negative 2 times plus 1 multiplies to be negative 2. And they add, negative 2 plus 1 adds to be negative 1, the sign in the middle. Now what do? Each equals 0, right? Remember the logic there? Because if two things are multiplying, parentheses mean multiply, two things are multiplying to equal 0. The first one could equal 0, or the second one could equal 0. Right? If two things are timesing to equal 0, either one could be 0 to make them multiply and be 0. And then just jump the minus 2 to the other side, or just add 2 to both sides. X is plus 2. Same thing here. Jump it over. Negative 1. Subtract 1 from both sides. So there's the x values. Now, each of those x's will lead to a y value that goes with it. And so we grab the top equation, bring it down. Y equals x minus 1. I'll put it in both places. And then plug in the x. So grab this x, plug it in. Y will equal 2 minus 1, 1. So that's x2, y1. The x2 led to the y1. And the second one, y equals, plug in the x of negative 1 right there, negative 1 minus 1, y, which is negative 2. I'll just do it on that same line right there. So y equals negative 2. So that's the x negative 1 led to the y negative 2. Right? X negative 1 led to the y negative 2. There are our two answers. How do they want us to put those in? Let's go back and see what they're saying. They're saying they want the x1 to be lower than the x2. So put the lower x first. That's the negative 1, right? Our two answers were negative 1, negative 2, and 2, 1, right? Negative 1, negative 2, and 2, 1. But they want this is the x and the y, the x and y. They want the lower x first, the negative 1, and then the y that goes with that. And then the higher x, coming next, which is the 2, and the y that goes with that, the 1. There's the four answers. We got it. Number 4. So on this one, I'm going to do the same thing, but I'm going to take this top equation, and what I'm going to do, I'm going to get x squared alone by jumping this minus 2y to the other side. So that becomes x squared equals 26 plus 2y. So the negative 2y jumps to the other side, becomes a plus 2y. And then I grab that, and I'm going to plug that in for x squared in the second equation. So again, I'm doing the substitution thing. I just had to first get x squared alone in the top equation, find out what x squared is equal to. X squared is equal to 26 plus 2y. So in the place of x squared, I can put 26 plus 2y. Notice I don't have to put squared on that or parentheses squared or anything, because that's the whole x squared. That's what it says right here, right? The whole x squared, not just the x part, but the whole x squared is 26 equals 26 plus 2y. So the whole x squared can be replaced with 26 plus 2y. Plus 5y equals minus 9. So that's nice. Now I have an equation that only has y. So what is this? 26 plus 7y is minus 9. Let's subtract 26 from both sides. 7y is minus 35. And last step, divide by 7. Y is minus 5. So we got an answer for y. Y is minus 5. Now we're going to plug that in to either equation. It doesn't really matter. So I'll just grab the first equation like I usually do up there. So grab this first one, bring it down. X squared minus 2y is 26. Plug in the negative 5 there. X squared minus 2 times negative 5 is 26. And that means x squared plus 10 is 26, right? The two negatives multiply to be positive. So bring this up here. X squared plus 10 is 26. How do you solve this? Just subtract the 10 from both sides. And the x squared is 16. And then, what do you do when you have an x squared like that? You just put a root, but don't forget plus or minus. Really common mistake is to forget the plus or minus. That's why I made up the dorky saying, when you put a roof on the house, you got to go up and down the ladder. So when you put a root on both sides, like putting a new roof on your house, if you're going to put a new roof on your house, you're going to have to go up and down the ladder to get up there and put the roof on. So if you put a root on both sides, don't forget the plus or minus. That's like the up and down. Sorry, that's the best I can do. Plus or minus 4. Square root of 16 is 4. So that means both these answers, plus 4 and minus 4, both go with a y of negative 5. So that means 4, plus 4 negative 5, xy, comma, minus 4 negative 5, xy. So both the x value plus 4 and minus 4 they both came from plugging in y is negative 5. see how they want us to enter these. So on number 4 here, they're saying do the one with x less than 0. So the two answers I got is plus 4 minus 5 and minus 4 minus 5 xy. So they want the x value less than 0, so that would be this one, minus 4 minus 5. Then they want the x value greater than 0, that would be this one, plus 4 minus 5. There we go. Number 5, now this one I'm going to do a different plan. I'm going to add up these two equations. Do you see why? Because these y squareds will just drop out. So this one is set up, number 5 here, is set up very nicely so that if I just add these up, the y squareds drop out. So what does that give us? 1x squared and 1x squared, 2x squared, and 6 and 1 is 7. The y squareds just drop out. So that's really nice. Now let's solve for x. How do we solve that for x? We divide by 2 on both sides. And so we get x squared is 7 halves. And now, how do we get that alone? What do you do when you have a x squared? Let me bring it down here. We're going to root it, right? We put the root over this side and the root over that side, and don't forget plus or minus. Plus or minus. So this cancels. So x is plus or minus. Now that square root goes to the top and to the bottom. I'm just going to leave it that way right now. They just want decimals in the end, so I don't care about that square root in the bottom. In fact, I'm just going to leave it the way it was. I'm just going to break it into two answers. We got x is plus, square root of 7 halves. And over here, and I'll go over here and I'll say we have x is minus square root of 7 halves, right? We have two different answers, plus or minus square root of 7 halves. Now each of those x values, let's start with this one, I'm going to grab the first equation and plug in, so x squared plus y squared is 6. Each of these x values is going to lead to actually two different y values. I'll show you. So let's take this x and plug it in right there. So that is negative square root of 7 halves squared plus y squared is 6, right? Just plug in that x. Squaring the negative makes it positive. It removes the root and makes this positive, doesn't it? So it's going to be positive 7 halves. See what happened there? The second power cancels the root. Remember, roots and two powers are opposites of each other. They cancel, and the negative, two negatives makes positive. That's canceled out as well. So we need to finish solving this. What could we do to finish this? You could just, there's a lot of different ways to go here. You could just make this, just subtract 7 halves from both sides, and so we get y squared is 6 minus 7. Now how do you subtract that? Well, you put this over 1, multiply top and bottom by 2, don't we? So y squared is 12 halves minus 7. Now 12 halves is a fancy 6, isn't it? So that subtracts to be 5 halves. So y squared is 5 halves. And so that means, what does that mean? That means y squared, let me bring it over here for a minute. Y squared is 5 halves. So let's square root plus or minus, right? When you put a roof on the house, up and down the ladder, don't forget about that. So we get plus or minus root of 5 halves. Both of those came from the answer x is negative root 7 halves. Let's get rid of this other x. We'll do the other one on a separate paper, separate sheet. So in other words, what we have is the answer for x negative root 7 halves. It led to the positive root 5 halves for y, and then that same x led to the negative root 5. We have these two answers so far, and we're going to get two more. Does that make sense? The y negative root 7 halves, I plugged it in, did all this work, and got down, I'm sorry, the x, I say y, the x negative root 7 halves. I plugged that in, did the work, and it led to two different y answers, plus or minus root 5 halves. So the x negative root 7 halves led to a y plus and a y minus root 5 halves. So there's two answers. And now we got to do the other x answer. Remember when we square rooted right here, we got plus or minus root 7 halves for x. So this was the minus root 7 halves, led to both those y values. So that was two complete different answers. Now we got to do the x is positive root 7 halves. Do that over here. Positive root 7 halves. And again, I'm going to plug in to just grab the first equation. X squared plus y squared is 6. Plug this in for x right there. So positive root 7 halves. The root cancels the square. And we get 7 halves plus y squared is 6. How do we get y alone? Subtract 7 halves from both sides. Boom. So y squared is 6 minus 7 halves. Here we go again. Put this over 1. Top and bottom by 2. Common denominator. 12 halves. That's just a fancy way of writing 6. Minus 7 halves. 5 halves. So bring it up here. So y squared is 5 halves. You know the deal. Roof on the house, up and down the ladder, right? Plus or minus. So y is plus or minus root 5 halves. Both of those, the same two answers we got for the other x, both of those are coming from the x positive root 7 halves. So the x positive root 7 halves leads to positive root 5 halves for y. And that same x positive root 7 halves leads to negative root 5 halves for y. Right? That same x leading to two different y's. So we got two other complete answers. So 4 answers altogether. So we got these two, and then we've got these two. Basically, it's all the plus and minus options of root 7 halves for x and root 5 halves for y. So basically, we have root 7 halves for x. Oops, I'm not writing that very neatly. Root 7 halves for x, root 5 halves for y, and there's plus with plus, plus with minus, minus with plus, and minus with minus. It was all 4 options on those. So if you use your calculator, crank out those numbers, you'll get all the numbers that they have right here on your calculator. And they tell you which ones they want the x less than 0, y less than 0, then the x less than 0, y greater than 0, etc. They want them in that particular order. So that's how we put them all in on our calculator. Number 6. A rectangle has an area of 150 square centimeters and a perimeter of 50. What are its dimensions? What's the length and what's the width? Okay, well, do you remember for a rectangle, you know, rectangles like this, if you have a rectangle, suppose your rectangle was 2 by 4, right? 2 squares tall, let's say. Let me just make up an example here. Let's suppose that it's 2 squares tall and, 4 squares wide. How many total squares? 1, 2, 3, 4, 5, 6, 7, 8. So the area of a rectangle is just one side times the other, isn't it? If you want to know how much space inside of a rectangle, the area, it's just one side times the other. So they're saying the area is 150. So the area, length times width, is 150. There's our first equation. And now perimeter is how far around the outside edge. That's what perimeter of an object means. So if you right here, how far is that? That's 4. How far is that? 2. 4, 2. So it's 4 twice and 2 twice. Perimeter is 2 lengths plus 2 widths, and that they're telling us is 50. So you see how perimeter, you just add up the 4 edges, which is 2 lengths and 2 widths. That's how far around the outer edge. And the area, the space in the middle, you just multiply one side by the other. So the area is multiplying, whereas the perimeter is adding up. Okay, so there's our 2 equations. Let's go to a separate sheet, and we'll solve those 2 equations. Okay, so there's our 2 equations. How we gonna do it? Well, there's a lot of things we could do. Probably one of the easiest things is if you take that second equation, notice you can just divide through by 2. Well, here, let's do this. Just solve for L or for W. It doesn't matter which one. I'll just jump this W to the other side, so we get 2L is 50 minus 2W. And then divide through by 2. Boom, so we get L equals 25 minus W, because these 2's cancel. So that's all from the second equation, isn't it? I solved for L, so now take that and plug that in for L in the first equation. And so what do we get when we do that? We get L times W is 150, but L is now, well, here, let's bring it down here. It'd probably be better. I shouldn't have written it over there. So we take L times W is 150, and then just plug in there for L. So 25 minus W times W is 150. Okay, and now just distribute. 25W minus W squared is 150. All right, so we have an x squared equation. What's the plan for an x squared equation? How do we solve? So solving x squared, or in this case W squared, step 1, get a 0. Remember, it's all about 0. And W squared on the side where it's positive, right? So I'm going to actually, on this one, jump everything to the right side. Why? Because W squared is negative on the left. Therefore, if I jump him to the other side, he'll become positive, won't he? He'll become positive W squared. The 25W jumps over, will become minus, and the 150 is already over there with a 0. Does that make sense? So the 150 was already over there on the right side. He didn't go anywhere. He's what he's always been, positive 150. But the minus W squared jumped over, became plus. The plus 25W jumped over, became minus. Why'd I do all that? Because that gets me a 0. So what I'm trying to do is get 0 on one side. I want to get rid of everything from one side or the other so that I have 0 on one side. And I want W squared to be on the side where he's positive. So I had to jump everything to the right side. Okay, so let's take that to a fresh screen. Okay, so now how do we solve this? Let's use the quad on this one. W will be negative B plus or minus the square root of B squared minus 4AC all over 2A. You could factor it as well. It's a little bit tricky to factor. So the A is 1, the B is minus 25, and the C is the 150. So what do we got here? So the W will equal negative B, negative 25, that's positive, plus or minus square root of B squared minus 25 squared minus 4 times A times C all over 2A. 2 negatives there, positive, plus or minus square 25 squared. Calculate negative 25 squared would be positive 625 minus 600 all over 2. This comes out 600. So that is 25 plus, whoop, I'll try that again, plus or minus the square root of 25 all over 2. And so that cleans up to be 25 plus or minus 5 over 2, right? The square root of 25 is just 5. So that means W is 25 plus 5 over 2, which would be 30 over 2, 15. Or the other option, W is 25 minus 5 over 2, which is 20 over 2, so W is 10. So W is either 15 or it's 10. Now, they specifically said, if you look back to the problem, so W is either 15 or 10, and then the length is the other one. It doesn't, in general, it doesn't matter which one you call length and width, but notice what they said on this problem back here. They said they want the length to be greater than the width. So the two answers are 15 and 10. So the length is the 15 and the width is the 10. The length is the 15 and the width is 10. Just because they said they wanted length greater. Really, in real life, it doesn't matter which one you call length and width. That's why we got the two answers for width here, because it doesn't really matter which is which. The width could be 15 or it could be 10, and then the length is just the other one. But they specifically said, hey, we want the length to be the bigger one, so there we go. The length is the bigger one.